Hello everyone, greetings for the day. This is the video demonstration of the task 6.1p of embedded systems development. Uh, in this pitch, we are going to pitch our project. Moving ahead to the introduction part, I'm excited to present our project, which is Smart Garden Monitoring System. The idea behind this project is simple yet powerful. We want to make it easier for people to take care of their plants, whether it is in a small garden or it is a larger greenhouse setup. By using IoT technology, we are able to monitor soil moisture, temperature, and humidity in real time. The system is designed to send alerts when attention is needed, helping reduce water waste and preventing plant stress. Let's take a closer look at how the system works by looking at the problem statement. For the problem statement, today most home gardeners and small scale agricultural practitioners struggle with one key issue, which is inconsistent plant care. Whether it's about forgetting to water the plants or not knowing the exact environmental conditions, manual methods just don't work anymore. Inconsistent watering, for example, leads to poor plant health or even crop failure. We realize that there's a need for a smart solution, something that continuously keeps tracks of the garden's vital conditions like soil moisture and temperature and humidity. A system that not only monitors but also notifies the user when it's time to take action. That's where our project comes in. Now let's briefly describe our project. Our project is an intelligent setup that helps users keep track of their garden's health automatically. It uses sensors to gather data like how moist the soil is, what the humidity levels are, and the current temperature. What's unique in this is that we have split the work across the two devices. The Raspberry Pi acts as the brain, it logs the data and can be used for visualizations. The Arduino Nano 33 IoT is optional but powerful. It can send real-time notifications using IFTTT whenever the soil gets too dry. The combination makes the system both efficient and responsive, providing peace of mind to anyone caring for their plants, whether it is in a backyard or a balcony. Now let's take a look at the hardware that we have used. The Raspberry Pi 4 would act as a central controller, while the Arduino Nano board is an optional addition that helps with the real-time alerting through IFTTT. Our sensors would include a soil moisture sensor and a DST22, which would capture both humidity and temperature. Everything is would be connected through a breadboard and jumper wires, making the system flexible for testing and further updates. Now coming to the block diagram part, this block diagram shows how each part of our system fits together. On one side, we have the sensors feeding real-time environmental data, which would be moisture, humidity, and temperature. The Arduino Nano board, marked as optional, plays the role of alerting the users instantly using IFTTT webhooks. Meanwhile, Raspberry Pi is handling the heavy lifting. It logs all the incoming data and would store it in a CSV file or a database, and we can use it, which can later be used to visualize trends over time. Now let's take a look at how the system works step by step. First, as the sensors read the environment, which is through the soil moisture sensor and the DST22, these readings are checked against the set limits. If, for instance, the soil is too dry, the additional Arduino Nano 33 IoT board will immediately send a notification through IFTTT. At the same time, the Raspberry Pi continues to record the data so users can track their garden's condition over time. This real-time feedback loop would ensure that the gardeners can take quick action, which makes the system both proactive and preventive. Now coming to us the conclusion. In conclusion, the system makes gardening way smarter and simpler. It helps users by notifying them when action is needed and logging data to improve plant care over time. Looking ahead, we could enhance the system by adding automatic watering and connecting it to cloud platforms for remote monitoring, or even making a mobile app. With further enhancements, this project could evolve into a full-fledged smart agriculture platform. Um, it's an if affordable and flexible solution for anyone who wants to take care of their garden using technology.